This is part 2 of lesson 7-2. We've been talking about division properties of exponents. So previously, in the last part 1 of the last video for 7-2, we went over some rules of exponents, right? So we talked about some multiplication rules, right? When we have several different variables or several different factors being multiplied in parentheses and all of them being raised to an exponent, we can actually distribute that exponent to each factor, which is what we did here, okay? When we have a base raised to an exponent, if that base has an exponent itself, we multiply the exponents together. So this would become a to the 3 times 4, which is 12, a to the 12th power. Oh, we didn't, right? Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We just multiply it together and get a to the 12th. I didn't complete it, sorry. Number 3, when I multiply bases, I add exponents, right? So here I'm multiplying a to the 3rd times a to the 4th. So my base is a, and I'm going to add 3 plus 4. So I get a to the 7th, right? So make sure you understand the difference between these two. Number 4 and 5, we started talking about division. So when I multiply bases, I add exponents. When I divide bases, I subtract exponents, right? Easy fix, we can figure that out. And then if I have the base being divided and then raised to an exponent, I actually distribute that exponent to the both pieces of the base, right? The top and the bottom if you write it as a ratio. If you didn't write it as a ratio, if it was like, if I had like a divided by c to the 3rd power, I would distribute that 3 to this guy and to this guy. So it would become a to the 3rd divided by c to the 3rd. We're just distributing that exponent to everything inside the operation here. All right, so we're going to add on 2 more rules real quick here. First rule is, and we talked about it in the last video, anything raised to the 0 power is 1. So for example, my red pen, if I had 37 raised to the 0 power, the answer is 1. If I had 1/8 raised to the 0 power, any base raised to the 0 power just equals 1. It's no more complex than that. The whole entire answer is 1, not just the exponent. The entire thing is 1. What's 5 million raised to the 0 power? 1. Always 1. Okay, and then number 7 here, what happens if I have a negative number in the exponent, right? Well, I want you to think of this as like a house with a basement, right? And you have your house with your basement in it. Florida, we don't have basements, but you guys all know what that is. If there's a negative exponent, it's telling you that the base is on the wrong floor, right? So if it's written like this is saying it's on the 1st floor and there's a basement below it. So you're going to bring this whole term down to the basement. And once you do that, we have a 1 left on top. This a to the negative 4 comes to the basement and the negative sign goes away. Once it's on the correct floor, it doesn't need a negative sign anyway. The negative sign just tells us it's on the wrong floor. What if we started with this guy, right? We have the regular floor in the basement, but it's got a negative exponent. So that means it's not supposed to be in the basement. It's supposed to be up here. So we're going to flip-flop it. And it's going to be a to the 6th. When you move it, the negative goes away, over 1, because I just flip-flopped them, which is just a to the 6th. Okay? So when you move a number up or down to the correct floor, in its place, you leave a 1, right? It's like a placeholder. You always leave a 1. So hopefully that makes sense, but we're going to work on it a little bit. That's what this whole lesson is about. So the 0 exponent property just says for any base that's raised to the 0 power, the answer is always 1. And the negative exponent property just says whenever you have a base raised to a negative number, a negative exponent, you're basically going to flip-flop where it is. So if it's already on top of a fraction, you're going to bring it to the bottom. And when you bring it to the bottom, the negative sign goes away. If it's on the bottom of a fraction and it's got a negative exponent, you're going to bring it up to the top and the negative sign goes away. Okay, I hope that's making sense. So let's do a few examples down here. I'm going to zoom in because they're written so tiny. All right, so we can think of this as in two different ways. We've got 2 squared divided by 2 to the negative third. The first way you want to think of it is, all right, 2 squared is in the right spot, but 2 to the negative third is not. So we want to bring this up to the top floor. And everything side to side is being multiplied. So if it's on the top, it's getting multiplied together. If it's on the bottom, it's getting multiplied. If we move something from the top to the bottom or the bottom to the top, we're going to multiply it by whatever's left. Okay, so this 2 to the negative third is going to come up to the top, and it's going to be 2 to the third, right? It was 1 over 2 to the negative third. We brought it up to the top, left a placeholder, and the negative sign went away. And then you don't have to write the 1 on the bottom of a fraction. Okay, so now we know how to do this, right? When we multiply bases, we add exponents. So that's 2 to the 5th power. And then I can go ahead and multiply, right? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. This is 32. All right, so that's one way you can think about it, bringing it up. The other way is if you don't want to move the negative sign, it's just you've got a base here and you're dividing, so you're going to subtract exponents, right? Your base is, mess myself up here, your base is 2, and your exponent on top is 2, and on bottom is negative 3. So you're going to say 2 minus negative 3. Right? Remember, top exponent minus the bottom exponent. Top minus the bottom. And when you have a double negative, it becomes a plus. So this becomes 2 to the 5th power, which is 32. Making sense? Kind of, sort of. All right, number 2. Same thing here. This is m to the 1st power. So I can either say, okay, my base is m, oops, and I'm dividing bases, so I'm going to subtract exponents, 1 minus negative 4. So that's going to become m to the 5th. Or you can say, all right, well, this negative, this isn't supposed to be down here since it's got a negative sign, so I need to move it up to the top of the fraction, and it's just going to become m to the 4th up here. So I'm going to have m times m to the 4th. And when you multiply bases, you add exponents. 1 plus 4 is 5. So whichever way you want to do it, you get the same answer at the end. Okay, number 3. Here, same thing. We can do our base is p, so we can do, what is this, negative 8. My eyeballs are not good. Yeah, negative 8 minus 3. So that would be p to the negative 8 minus 3, which would be p to the negative 11. And then, of course, I can't leave with a negative sign. So think of this as being over 1. It's got a negative exponent, so it needs to come down to the basement. It's on the wrong floor. So I want to make it 1 over p to the 11th. Okay, the other thing you can do is just say, okay, well, this p has a negative exponent, so it's on the wrong floor, so I need to bring it down here, right? So I'll have 1 over, and I already have p to the 3rd down here, and then I'm going to multiply it by this p to the 8th that I just brought down. And that's 1 over p to the 3rd times p to the 8th. Multiply bases, add exponents. 3 plus 8 is 11. Okay, so either way you want to solve it, you're following the correct properties. You get the same answer, so it doesn't matter which way to me. This is one of those lessons that I prefer so much to teach in class because just telling you about it here it gets really confusing. But it's not confusing. It's a really simple lesson. Okay, so here, this b to the negative 4 is on the wrong floor, so we got to bring it down here. This b to the negative 5 is on the wrong floor, so we got to bring it up here. So it's going to become b to the 5th over b to the 4th, right? When we brought this guy down, it lost the negative sign. When we brought this guy up, it lost its negative sign. And so now I've got everything in the right spot. B divided by b, so I'm going to subtract my exponents. 5 minus 4 is 1. So b, 5 minus 4 equals b to the 1st power. And when it's to the 1st power, you don't have to write a 1. So it's just b. Next problem, number 5. Okay, here, the entire top here, before you do anything, is raised to the 0 power. So this entire top just becomes 1 over, and then we can look at the bottom. 4w negative 1, y, is that a 2? Yep. Okay, so the only thing out of place now is this w to the negative 1 power. It's on the wrong floor. Only the w, the exponent only applies to the base right in front of it. That's it. It doesn't apply to the 4. So this w to the negative 1 needs to come up to the top. And when it does, it's going to lose the negative, and it'll just be w to the first power. Okay, so I'll go w on top. And then it's not on the bottom anymore since I moved it up. So on the bottom, I'm left with 4y squared. And that's it. All right, I'm starting to like run these together. Let me skip around a little bit. We can do this one. So y to the 0 is just 1. This becomes x to the 4th times 1 over x to the negative 2. And then I see that this negative guy, this is in the wrong spot, so it needs to come up to the top, right? So it needs to be x to the 4th times x squared all over 1. And if all I have on the bottom is 1, I don't have to write it. And then when I multiply bases, I add exponents. 4 plus 2 is 6, so my answer is x to the 6th power. Easy enough. All right. I have to do a couple of these on scratch paper. Give myself some room. Let's copy this down and then do it on, oh, that's not a good scratch paper. All right, for number 8 here, we've got, let me just copy it, 6a to the negative 1, b, all that squared, all over b squared to the 4th. Okay, so now I can zoom out a little bit now that I've got it here. All right, so before we can touch anything inside parentheses, we need to get rid of the parentheses by distributing what's on the outside, right? So first thing I want to do is deliver this little exponent of 2 to each factor. So I'm going to have 6 squared times a to the negative 1 squared times b squared all over b squared to the 4th power. 2 times 4 is 8, so b to the 8th power. So now I've got this guy. Now I can simplify even more. I'm going to change this to negative 1 times 2 is negative 2, a to the negative 2, right? 6 squared is 36. I can go ahead and simplify that. A to the negative 1 times 2 is a to the negative 2, b squared all over b to the 8th. And then the only thing in the wrong spot here is this a to the negative 2. Nothing else is in the wrong spot. So I'm going to move that. It's on the wrong floor. I have to move it down here to the bottom, right? So I'm going to have 36. This is moving down to the bottom, and then I still have b squared on top. And then on the bottom, I moved this a to the negative 2, but when I move it down, it doesn't keep the negative sign, so it's a squared. And then I already had b to the 8th there. Okay, am I done? Not quite. Okay, so now I want to simplify the b's, right? There's no numbers to simplify. There's no a's to simplify, just b's. So I'm going to have 36 times my base of b, and I'm going to subtract top minus the bottom, 2 minus 8, all over a squared. And then I just have one more step to simplify, well, 2 more steps to simplify. This becomes 36b, 2 minus 8 is negative 6, all over a squared. And of course, now that I've simplified my b base, now it's in the wrong spot. Now it's got a negative exponent, so I need to move it down here, right? So my final answer is going to be 36 over a squared b to the 6th. Done. I'm literally just following all those rules that we went over, so make sure you have those all written down somewhere. I find that super helpful to just write them down so they're in front of me and I don't have to go back searching for them. Kind of like I did these examples here with you guys. Back up a little bit. Numbered from 1 to 7 and gave myself an example of each property, right? Just go back and do that. Okay, so that was number 8. Let's pick, maybe I'm going for 15 minutes. Let's pick like 2 more to do. Let's do 2 more. All right, so let's do number 9. And, oh, we'll do 3 more. That's a good one. 11 and 12. We'll do those 3. And I'll do them on this separate sheet of paper. So we have room. Number 9. I got to scoot back in here so I can read that. All right. First thing I want to do is copy everything down. 3RT squared times u to the negative 4 all over r to the negative 1 t squared u to the 7th. Okay, once I have it written down, then I don't have to zoom in so much. Sweet. So now I can simplify. First thing I want to do is get rid of parentheses. Remember when you use PEMDAS to solve, you're still using it in this other math, right? We're still using parentheses, exponents, multiplication, divisions, addition, subtraction. We're still going in that order. So I've got parentheses here. I got to simplify the exponent by distributing it. So this is going to become 3 squared times r squared times t squared, and then I still have this u to the negative 4 on the end, all over r to the negative 1, t squared, u to the 7th. Okay, so what do I notice right away? First thing I want to do, actually, is anywhere I see a negative exponent, I want to make sure I move it, because I don't want to deal with negative signs. Like, it's too, I don't like dealing with that. So this u to the negative 4 and this r to the negative 1, they're both in the wrong spot. So this guy needs to come down. This guy needs to come up to the top. So that's what I'm going to work on first. 3 squared, or you can go ahead and change that to 9. We're going to do it in a second. Times r squared times t squared. And then this isn't going to be here. It's going to go to the bottom. But I'm going to bring this r up to the top. So it's going to be r to the 1st power. And then on the bottom, I just got rid of the r, I moved it up, so I've got t squared times u to the 7th times, and then I moved this u to the bottom, so the negative sign goes away, and it's just u to the 4th. Okay, so now I can simplify. And keep going this way. 3 squared is 9. R squared times r, when I multiply bases, I add exponents. That's r to the 3rd times t squared all over. And then on the bottom, I've got t squared. And then u to the 7th times u to the 4th. I add, when I multiply bases, I add exponents. 7 and 4 is 11. So that's u to the 11th. Okay, can I simplify anything else? I don't have any plain numbers on the bottom, so I can't do that. I don't have any r's anywhere, can't do that, but I do have t squared, right? And then I don't have any more u's. So the only thing I can simplify is this t squared, right? And let's for a second, let's flip-flop the t and the u, because I can do that with multiplication properties. T squared all over u to the 11th t squared. Okay, so now I have the t's lined up, and t squared divided by t squared, they just cancel each other out, right? 2 minus 2 is 0, and t to the 0 power is just 1, just goes away. So I'm left with this fraction, 9r to the 3rd over u to the 11th power. That's my answer. Okay, sorry, so that's number 9. Then let's go back to number 11 here. Let's copy that down and then simplify. Find myself a blank area on my sheet of paper. All right, so I've got, oh, I don't have to copy it down. What do you know? Okay, see this whole big tricky thing. All of it's being raised to the 0 power. And what is any base raised to the 0 power equal to? Boom, 1. You don't even have to do any of this, right? If it's all being raised to the 0 power, the answer is 1. Easy peasy. So then number 12, now we can simplify this guy. I'm gonna copy it down and do it on my paper. Negative 2mn squared to the negative, what is that, negative 3? Yep. My eyeballs are getting so old and blurry. And then 4m to the negative 6 and to the 4th. Okay, so here's our problem. Back up a little bit. First thing I want to do is go ahead and, since this whole entire thing is being raised to a negative exponent, I know all of it's going to move to the bottom, right? So this inside parentheses will stay the same, but this number, because this is our base, this number will become a positive 3 when we move everything to the bottom, right? And what's the other thing that I can move? On the bottom, this guy has a negative exponent, so it can come to the top. So this entire thing needs to come to the bottom, and the m to the negative 6 needs to go to the top. So we can rewrite this as m to the negative 6 comes to the top, and it's just m to the 6th. And then on the bottom, I'm left with 4 times n to the 4th. And then in parentheses, all of this, negative 2mn, mn squared, raised to the positive 3rd power. That exponent that was negative becomes positive when we move it down. None of this changes because it's the base, right? The thing that made this on the wrong floor wasn't any of this, it was just this negative 3. So when we move this whole thing, it all stays the same, but the negative 3 becomes positive. Okay, so now I can simplify. The next thing I want to do is parentheses here. I want to distribute that exponent 3. I could have done that first here, but then all of these would have ended up with a negative exponent, and I would have had to move all 3 down. In this case, since the whole thing had a negative, I could just move the whole thing down. Okay, so I want to leave m to the 6th alone on top, 4n to the 4th on the bottom, times negative 2 to the 3rd, times m to the 3rd, times n squared to the 3rd. 2 times 3 is 6, so that's n to the 6th. All right, so now we're here. Okay, I can go ahead and I'm gonna change this plane number and multiply my plane numbers together, right? So negative 2 times negative 2 is positive 4, times another negative 2 is negative 8. So I'm gonna have 4, just on the bottom here, 4n to the 4th times negative 8 times m to the 3rd times n to the 6th. I want to combine the 4 and the negative 8, so that's negative 32. I can combine my n's, right? N to the 4th times n to the 6th. 4 plus 6 is 10, so that's n to the 10th power. So I've used these two, I've used this one, and then I have m to the 3rd. That's all on the bottom now. So I replaced this with this bottom. So I can rewrite the whole thing now. M to the 6th all over, negative 32, n to the 10th, m to the 3rd. All right, so the only thing left to simplify now are these m's, right? It's the only thing that I've got on the top and the bottom. So m divided by m. When I divide bases, I'm going to subtract exponents, right? And I'm going to do it, this comes up to the top, right? Unless this is negative and we bring it down here on the bottom, whenever you're dividing bases, the answer always floats to the top. Now, if the answer has a negative exponent, then you'll move it to the bottom, but it automatically starts out in the top. So this is going to become m to the 6 minus 3 all over negative 32 n to the 10th. Oops. right? So this m divided by m, I just wrote it in the top, 6 minus 3. Okay, and last thing to simplify now, 6 minus 3 is 3, so that becomes m to the third power over negative 32n to the 10th. All right, so those are all the problems that we have gone over here. There were a few more, but it's cumbersome. So let me know if you guys have questions. Yes, it was a lot of combining a whole bunch of properties, but all of your properties are listed. If you missed it in the video, or you want a quick way to write them down, in every lesson folder, I always put up your video, and right below the video, I put a copy of the study guide, which are the notes that I fill out in the video. So you can always go back and look at just the blank study guide and write down these properties from 7.1 and 7.2. Okay, let me know if you have questions.